This is a production of Cornell University.
Well, great. Thanks a lot for the introduction, Andy. Yeah, as Andy mentioned, I'm just beginning my second year, and these are really some initial thoughts for my research plan. I'm really looking forward to your feedback and questions at the end or another day if we run out of time. But I'm going to be talking about some of our research related to agricultural burning in Bihar, India. Oops. There we go. All right. So the area of interest that I'll be talking about today is Bihar State. It's on the eastern side of the Indo-Gangetic Plains. And our lab group works very closely with CIMMYT in South Asia, and particularly CISA, the CISA team, the Cereal Systems Initiative for South Asia. And this group works on multiple sustainable intensification challenges in cereal systems. Now, Bihar in particular is a major priority region for the government of India in their future food security goals. This area has a very, unfortunately, astonishing yield gaps. And there's been a lot of investment in multiple different capacities to intensify agriculture. But then, of course, with this intensification also results in some increased environmental pressures and other sustainability challenges, such as burning. So we got together a group of people, like Andy mentioned, to apply for the Atkinson Center Academic Venture Fund. And so we were able to bring together, excuse me for a moment. We were able to bring together a really multidisciplinary team from across Cornell and CIMMYT, bringing together individuals in agronomy, atmospheric sciences, policy economics, even anthropology, to really look at the changes that are happening in Bihar and from a very multidisciplinary, multifaceted approach. So it's exciting to be a part of this. But first, let's start off and I'll get on the same page on what crop residue burning is in the context of South Asia. Now, burning is a method used to quickly remove crop residue from the surface and clear the field for the next crop. These are primarily rice and wheat systems, and burning tends to happen with, or is most common in the rice with the rice residue. And it's an approach that's taken when the straw has little to no value. So that could be that once maybe the straw had a value as a livestock fodder, but not anymore, or the economics just don't match up between what it would cost time and money to remove it and transport it. And so essentially lighting a match and burning it is unfortunately a quick solution to get rid of the residue. But this unfortunately does contribute to major air quality issues and public health issues. And actually we are in a timely This is a timely moment for this talk. We're entering right now, beginning of November, the peak season of residue burning and air quality issues in Northwest India. Some say that it's equivalent of 2 packs of particulate matter, 2.5 per day. And schools close, it's really bad situation air quality wise. But burning also contributes to long-term yield decreases due to decreases in soil quality, and then also has negative implications on greenhouse gas emissions. So here I have a screenshot from last year during the 1-month peak burning season of rice straw. And you can see here in the western Gangetic Plain, that the fire count, so each red point here is a fire observation from a satellite. So we have the Northwest being the primary hotspot for burning. This time of year, coupled with other environmental conditions, it just creates this massive air quality crisis in the region. And there's been a lot of investment to try to deal with this issue with patchy success. For those of you who aren't familiar with this context, in India, it's considered the breadbasket of India, and a very intensive rice wheat system, irrigated, mechanized, particularly with combine harvesters. And actually the combine harvesters have a very close link with burning that I'll talk about in more detail later. But our area of interest for today, and I'll just note that we are doing work in the Northwest, but I'll focus on Bihar for today's talk. In the East, only about 10% of farmers are burning. But what's alarming is that this rate has doubled in the past 10 years. This is just a quick time series plot of the last 17 years. And this is an annual fire count from across the state. And you can see that this upward trend is really alarming. And it puts major concern, or brings into major concern of what air quality might look like in Patna in 5-10 years if this continues. Patna already is struggling with air quality issues, and this type of scenario in 5-10 years could really put Patna at the risk of some of the challenges that Delhi area is, and New Delhi specifically, are facing with air quality. So this research presents a unique opportunity to get ahead of this emerging problem. Essentially understand this issue before it's too late, or the problem is already so massive that it's difficult to handle. So it's a unique opportunity to, one, use geostatistics to understand what's going on with burning, and then also our on-the-ground agronomic networks to, like I said, quantify what's happened with burning and the reasons behind it, and hopefully use these pieces to inform policy. So I mentioned very briefly that agriculture is intensifying in the state. But more specifically, I'm just going to pull out a couple other pieces of other hypotheses that we think are driving these recent increases in burning. So first off, we have changes in labor availability, specifically labor shortages. And this really mediates combine use, mechanization, but specifically combine use, and also livestock ownership at the household level. Now, traditionally in these systems, rice was harvested by hand, or is still in many places, right? It's harvested by hand, bundled and stored and fed as a livestock fodder. Now, with labor shortages, the combine is an attractive alternative. Unfortunately, with the combine, what happens with the straw is it gets fed into the inside of the combine, it gets bent, broken, and sent out the back, essentially rendering it useless for a fodder. It's very difficult to store as well. And so oftentimes the straw is burnt after the combine comes through. So, and then when it comes to livestock, in Bihar, these are extensive crop livestock systems. And we're seeing anecdotally a decoupling of the crop livestock system, and essentially a intensification or a consolidation of the milk value chain. So we're seeing a lot of different trends in this system that might be related to the change in burning. But zooming out a little bit, I'd like to present to you what the project that was recently funded by the Atkinson Center, Academic Venture Fund. And it has 4 main components. First, which I'll talk in more detail today, is naive and factor-based modeling of burning. We'll also be looking at air quality modeling and coupling that with disease burden estimations. And then also all of that feeding into scenario analyses of agricultural productivity and greenhouse gas emissions. And all these pieces will come together and provide evidence-based policy intervention design. But most importantly, it will be co-constructed with the state government of Bihar. And we're fortunate to be in this, it's good timing in the fact that Bihar officials are very concerned about these looming changes of burning. And yet little has really been studied and on this topic. So it's a good opportunity to form policy. So getting into the next 3 pieces, this naive and factor-based modeling of burning. We want to understand the what, why, and what's next. First, what's happening? We want to understand the spatial and temporal burning patterns of rice residue burning. And then why? What are the potential of drivers of change that are resulting in these burning patterns? And then finally, what's next? Develop scenarios of development trajectories and engage policymakers. So we'll begin with the what. Our data sources for understanding the past fire trends are our two Earth observation satellites, VEERS and MODIS. MODIS has the great benefit of having a long time span. Since 2003, we have a large amount of data. And VEERS, however, while it has a shorter time span, the spatial resolution is finer and does capture a larger or greater number of fires. One of the approaches we're using for these analysis is point pattern analysis. And I'll show you 3 plots here from 2012, 2015, and 2018. And just looking at these fire points from across space and time, a visual estimation shows us, yes, fires are increasing across the state. But you can also see there that the density of points is much greater in the western part of the state. And if you look closely, you can almost see the points moving from west to east, and which gives insight to some type of technology frontier per se. We can use fires as a proxy for combine adoption. And so in this way, remote sensing gives us a very unique opportunity to really understand technological change across time and space that we would not be able to do in this level of detail otherwise. For example, on the ground household surveys could provide some type of insight on combine adoption, but it'd be very difficult to get this level of detail and this expansive panel data of this information. So with point pattern analysis alone, we could predict future fire patterns, locations, locations and intensity, but it brings us to the why. If we can understand the drivers of change, especially thinking about how these drivers of change are likely to be heterogeneous across the state, and that there will be some variation, we can build prediction models that are much more detailed and can really strengthen our models. So thinking back to the hypotheses that I presented earlier, in the system, these drivers are complex, they're dynamic, and it will take a couple different efforts to understand what's going on in this system. So first, we'll be doing a series of household surveys. We'll also be conducting key informant interviews with individuals in the residue markets, individuals in the milk value chains, and then also individuals in the combine service provision. And while this piece of the research is very preliminary, we have completed the first step, which was the first round of a household survey across the state of Bihar in 30 of the 38 districts. And while these results are preliminary, I want to share a couple of things here that will give us some insight into some of these notions that we were thinking about earlier. So over the past 5 years, households reported that, yes, in fact, livestock ownership is going down, is decreasing. And at the same time, there's a notion that combine adoption is increasing. However, if you look to the plot on the right, what this is showing, this is the percentage of rice fields harvested by combine. So we asked individuals, okay, if you adopted the combine, what percentage of your rice fields did you adopt the combine? And you can see that the majority of individuals actually partially adopted the combine, are using it on 50 or 60% or so of their fields. Now, these individuals owned an average of 4.5 livestock per household. There were, however, full adopters using the combine on all their fields. These individuals own much less, 1.5 livestock per household. And so we asked these partial adopters, why? Why only partially adopt? And the majority responded that non-combine fields were mainly harvested to preserve straw for livestock feeding. And so we do get this sense that households that value livestock will adopt technology, but perhaps a little bit differently. And if they're adopting technology, the combine a little bit differently, that may result in different outcomes for burning. And so the story builds, but it does provide some insight into what might be happening and some of the complex dynamics of the system. And so finally, what's next? So thinking back to the four big objectives from this Atkinson Center funded project, we gather up all these pieces, essentially the burning models, the burning forecasts, understanding the drivers of change, having those integrated into the models, public health implications, crop productivity, greenhouse gas emissions. A lot of this is coming from other secondary sources. And we're bringing these all together to build scenario models to understand the burdens, essentially the burdens, the public-private cost of burning. And so the goal is to say, okay, in 5-10 years, if business as usual continues with burning, what's that going to cost? What's the public and private cost of that? But we'd also like to say, okay, there's some other alternatives here. If we look at alternative 1, alternative 2, that the costs will decrease, or maybe burning, depending on what happens, we can slow down or stop burning altogether. And so these really require a co-creation of creative solutions. In fact, you can see here on the left-hand side here, we have something called a happy seeder. And this is a piece of equipment that allows you to plant into deep residue, into thick residue. And this has really been promoted in the Northwest as a way to handle a massive amount of residue as an alternative to burning. And yes, from a practical stance, this can be a way to address this challenge, all this residue, but in reality, adoption is a bit scattered, it's a bit sparse, it's expensive. There's a short time between harvest and planting. So this alone, yes, while it can be helpful, we know that technology, mechanization is not the only solution. And so we need to think about solutions that may be related to rural infrastructure, maybe thinking about where milk drop-off stations are located to support the continuation of the crop livestock integration. Maybe the new solutions are related to residue markets and thinking about other purposes, or just kind of thinking about ways that these all relate and that burning can be addressed in this multifaceted way, and then leverage key points in the system. So thank you very much, and I look forward to your questions and feedback.
Emily, I have a question.
Sure.
Is there any use of post-combining baling of the straw to make it a little bit easier to handle and get it off more quickly? And secondly, another completely different alternative, a sort of chopping device that would be at the outlet on the combine that would chop that straw into smaller pieces that would be less objectionable to leave on the field.
Yeah, these are good questions. Yep, baling is definitely an option that a lot of people have looked at. And then the big question is, what's next? So having subsidizing machines to bale will essentially move the residue, get it out of the field. But there's really a whole value chain of thinking about what's next. So whether that's moving these bales into areas for livestock fodder or there's been other initiatives where the straw has been used as a biofuel, or it's been burnt. And the big challenge is the transportation and just making the economics viable behind that. As far as choppers, I know there's and we're actually seeing this from this first household survey, there is kind of a new business opportunity for service providers to provide chopping. So, and then storing fodder that way. But I'm not sure of any in situ field, and maybe Andy could actually speak to this better about the the choppers in field.
Actually, Emily, what I was
Yeah.
thinking is nothing terribly, not a really big deal. It's very common in combines that we use in small grains in the United States to have right at the outlet of the combine, it can chop it up into small pieces. And so that's just incorporated right into the combine. And it's a small power requirement, I believe. But it doesn't cut it into really, really tiny bits like in silage. It's cutting it into, I don't know, 6-8 inch pieces.
Which Tim is great if you have the equipment to sew into loose residue. I mean, it opens up some different avenues, but by and large, outside of the happy seeder, none of the drills can handle that. It does help a little bit with incorporation. And in some of the areas in Northwest India, they have a separate machine that is a straw chopper that runs behind the combines. I haven't seen it integrated. We have things like the straw management system, which spreads evenly, which makes it a little bit easier to sew into. But yeah, there's lots of things that could be done. In the East, it's all about cost, and it's a different equation.
Incidentally, Emily, what do they do with the wheat? They use the same combine?
So I know, so there's some different a little bit different dynamics with wheat. One of the key pressure points with the rice burning is there's a very short planting period between the rice harvest and the wheat planting. With the wheat harvest, there's a much longer delay, right? So a lot of it, essentially there's time to look at different solutions and do something with it. But there is also some burning with the wheat as well.
Yeah, and also after the wheat, it gets dry, right? So it's easy to get a good quality straw after the wheat because of the drying that takes place.
Yeah, that's a good point. Yeah, thanks for those questions.
Just one interesting thing, Emily, is that in the East, the farmers tend to feed rice straw to their animals. In the West, Northwest, they use wheat straw. And what happened, they've been combining first started in the Northwest. And so those farmers have actually switched from having animals, so your livestock from being there for tillage to actually switch to dairy. So they usually they will actually pick up the straw after wheat harvest and bale it and use that as feed for the rest of the year in Northwest. In Eastern India, a question is, are they switching when you say there's a reduction in livestock? Is this reduction in livestock due to a switch, just livestock per se, or are they switching from lamb preparation to dairy, which is what they've done in Northwest?
Yeah, no, that's a good question. I think that the true answer is we need to, this is part of trying to figure out what's happening with the livestock numbers. There's very little publicly available data on livestock numbers and what that is, whether they're for working the field or dairy. The other question is, livestock numbers might be going down at the household, but does that necessarily mean that livestock numbers, maybe there's just this consolidation of livestock production? So if you look at a statewide numbers, that livestock maybe hasn't changed so much. So this is an area where we definitely need to collect more data and understand. The key informant interviews, hopefully with individuals in the milk value chain, will hopefully provide some more depth into those questions. But thanks for that question and comment.
Yeah. I need to spend time talking to you.
Great. We'll make that happen.
Okay, great. Any other burning, so to speak, questions for Emily?
This has been a production of Cornell University, on the web at cornell.edu.